Hello, and welcome to the Math Dive in 5 for 4th grade, Multiplication Models and Strategies. I'm Shanna Uwe. For your first task, please pause the video. You're going to complete the task on your own or with a team or partner. You want to solve for the product. You can use an area model, partial products, and a standard algorithm to prove the solution for 12 groups of 16. As you're thinking through the task, how do the strategies relate? How do the strategies focus on place value? And why is it important to use the area model and partial products first rather than going straight to a standard algorithm? So go ahead and pause the video, complete the task, and we'll see you soon. Welcome back. Now that you've done the task, we're going to look at the progression within BEST for multiplication strategies. In 3rd grade, we're exploring multiplication of two whole numbers with products from 0 to 144. We're multiplying one-digit whole numbers by multiples of 10 up to 90, and also multiples of 100 up to 900 with procedural reliability. We're also multiplying two whole numbers from 0 to 12 with procedural reliability, that is by the end of 3rd grade. In 4th grade, we're multiplying two whole numbers up to 3 digits by 2 digits with procedural reliability, which means we're still using strategies based on place value, but they may include arrays, area models, and partial products with larger numbers. And then we're also multiplying two whole numbers up to 2 digit by 2 digit, including using a standard algorithm with procedural fluency. In 5th grade, we kind of extend off that. We're still using the similar strategies, but now we're multiplying multi-digit whole numbers, including using a standard algorithm with procedural fluency for any combination, and then exploring the multiplication of multi-digit numbers with decimals to the hundredths, also using estimation, rounding, and place value, and multiplying numbers with decimals to the 10th place by 1/10 and 1/100th with that procedural reliability. In this video, we're going to focus on the 4th grade standards where we're looking at arrays, area models, partial products, and how they all connect, and also how to connect them to a standard algorithm. So we're going to start with arrays and area models as the first strategies. We want to make sure we pick factors that are modeled easily so that we can kind of make connections between all the different strategies and kind of go through the entire progression. So numbers within 20 are really good to use with arrays and area models for factors. We want to consider that 3rd grade students coming in already have a good understanding of arrays and area models. They spend a lot of time in it, focused on it in 3rd grade with one-digit factors. So now we're just building off of that and trying to increase the value of the factors. So first we might start with, this is 12 groups of 16 like you did with your initial task. We might want to go ahead and model it with base 10 blocks so they see that equal groups model. Then we're moving into actually taking those groups and placing them in arrays so we can make a connection right there between the equal groups models and an array. And then we're taking off of that and now we're putting numbers to it and including those factors that kind of go with it. So continuing with arrays and area models, we're posing questions for students to see connections between the different models. And that scaffolding right there is how we support students in deepening their understanding of how place value relates to these models and strategies. So now that we have a sound understanding of representing multi-digit numbers with arrays using those base 10 blocks, we're going to build off that because you can already kind of see how the factors are broken apart by place value. And now we can do that with graph paper and representation of an array. So we're even taking off of that too, and we're showing all those partial products, right? Like really with those tens blocks, I have 10 groups of 10. And then over to the right, I have 10 groups of 6. So we're color coding it, we're putting the numbers to it, we're putting the partial products to it, and then at the end, we're combining it so that students can see where the total product came from. And then we're moving into open arrays. So now that we've had time with the base 10 block arrays, the graph paper arrays, we're moving into doing it without the graph paper, but it's the same situation. We're still having 10 groups of 10 equal 100 and 10 groups of 6 equal 60 and so forth. So continuing with strategies based on place value and understanding of partial products and area models and ultimately multiplication, Once they have that solid foundation on using those area models, and even those open area models we sometimes call it, to determine the products of multi-digit numbers, you can move to having them just use the numbers themselves using partial products. So once again, you would start with the array, and partial products are as it sounds. You find the partial products of the entire problem and then combine them at the end. So you can see here how we can make connections between the two strategies. Over here, I have 10 groups of 10 equals 100, 2 groups of 10 equals 20. You can see the same thing over to the right in the partial product strategy. Same thing here, 10 groups of 6 equals 60, 2 groups of 6 equals 12. I'm just multiplying those ones and combining them. So once again, we want to make connections between the area models and the partial products and have students able to verbalize those connections and how they're similar and different. So now we're moving to connect the area model to a standard algorithm. Once they're finding success with area models, arrays, partial products, and they're using those strategies successfully and able to connect place value to it, then it's a good time to introduce the standard algorithm, but not before then. We want to make sure that we're encouraging students to focus on that place value language as they move to standard algorithm so that they're understanding how all those strategies connect. So here, once again, we might want to connect an area model to a standard algorithm. We can do that by bringing back in those graph paper arrays. So show them again, get it fresh in their minds, and then move to, okay, now we can do it as an open array. But now, how does this strategy of a standard algorithm relate to what I've been doing with those open arrays? So once again, I can see that the same problems are there. I still have 10 groups of 10 and 2 groups of 10, but the only difference now is in a standard algorithm, I'm combining it as I go, where in the area model, arrays, and partial products, I was combining it at the end. So once again, having kids make those connections is essential. And then same thing over here. That 72, where did that come from? Where do you see it in the open area model? Oh, I see I had 10 groups of 6 equals 60 and 2 groups of 6 equals 12. If I combine that, that's 72. Oh, I did those same problems in the standard algorithm. Connections are essential. Another way to build understanding of a standard algorithm and how it works and relate it to a strategy that students are being successful with is connecting it to partial products. We want to make sure, once again, that they're focusing on place value even when they get to that standard algorithm. So by making these connections, it's going to really help. So you can see in the partial products, once again, have the same situation. I have the same two problems. On the right, in the standard algorithm, I combine it as I went. In the partial products, I combined it at the end. And we want the students to be able to verbalize the difference between the two strategies and how they relate and how place value is embedded. And this is why it's so important that we don't rush to a standard algorithm, that we focus on these strategies based on understanding and place value, and then relate it so that kids don't get lost in the steps. So to kind of recap the strategies that we discussed in this video, we have our CRA. We're thinking about concrete first, using those basin blocks and arranging them in arrays to make connections. And then we're moving into the graph paper representations of arrays, and then even moving to that open area model and moving to partial products and standard algorithm with just the numbers. Remember, in order to strengthen those bridges, we're going back and forth and making those connections, and we don't want to rush to the abstract until they have a really solid foundation of that concrete and representational. So I hope you got a lot out of this strategy for multiplication models and strategies, 4th grade. I appreciate you joining me today and can't wait to see you next time.